So today is the 6th, and we start with a problem from WebAssign. It's from 4.2, and it's number 4. So the graph of a function is shown. Which of the following verifies that G satisfies the hypothesis of the mean value theorem? So the mean value theorem states that for such a graph, let me share my screen actually. With Mark's permission. Mark, can I share the screen?
Yeah, absolutely.
Okay. It will only be just that problem. So here it is. As you see, the function is continuous on the closed interval 0, 8, and is differentiable on the open, at least on the open interval 0, 8. Okay. Then we have to estimate the value. So this is the mean value theorem. So I'm going to stop sharing for a second, just to write that f prime of c equals f of 8 minus f of 0 divided by 8 minus 0. Okay, back to sharing. Okay, so you estimated, so part B, enter your answer as a comma, separate around your answer to one decimal place. Okay, so, and the question was asked to determine, evaluate the values of C to satisfy the condition of the mean value theorem. So I'm assuming, so we don't have a function expression for this, right?
Correct. It's just the graph picture.
Right. So what you can do is, first of all, determine the slope of the tangent of the secant line between this point. I don't know why it does that, but anyway, I can show what I'm trying to say. Okay, so I'm trying to say this. So the graph is something like this. So I have to determine the slope of the secant line, and then estimate where two other points where the slope of the tangent line is equal to the slope of the secant line. So now I have to go back and estimate what was f of 8. Sorry, I didn't look. So f of 8 is 1, 2, 3, 4, I believe. F of 0 is 1. And then over 8 minus 0, which is 8. So this is 3 over 8. So now I have to estimate this point where these x values, in other words C1 and C2, where the slope will be the same with 3 over 8. So it's a little bit difficult to do this on the computer, right? So on paper would be a little bit easier. So so then we came up with, let's take a look again. So I can draw, or even envision that I draw a line. I don't know how you did this, but I commend you for doing it. So it's probably close to 2 point. I can't. I just can't hover the mouse over it. Okay, so now that's the difficult part, because I can't even, it just pops up with all sorts of stuff. Then estimate the values of C that satisfy the condition of the mean value theorem on the interval 2, 6. So I will have to do the same thing with 2, 6. So I will have f prime of C equals f of 6 minus f of 2 divided by 6 minus 2. So again, f of 6 I can easily determine. That's not a big deal. So what was f of 6? 1, 2, 4, 6. F of 6 again is 1, and f of 2 is 3. Okay, stop sharing. So then I got negative 2 over 4 or negative 0.5. So this time the slope of that line is, so if this is 0 and this is kind of 1, so something like this. This will be a slope of negative 0.5. But again, I have to find, so that's the difficult part again, because I can't show what I'm doing because of that information that pops up. So once I have the 2 points, which is one is here and one is here, then I draw the secant line, and then I'll try to find 2 other points. So obviously one is up here at the top and one is here. So that's a little bit of a weird situation. My apologies. I'll inform my colleagues that this is not the best type of problem.
Thanks for going over it.
Oh yeah, of course, anytime. So that's really not, because it's not easy to put all this in perspective, especially if you cannot even draw or imagine you draw on the graph. Like I couldn't show you more. Very good question. Thank you for pointing that out to me. I'll make sure that you get the credit for that, in case you didn't. Okay, next question. Anything you would like to ask? Anything, anyone? Anything? Okay, in that case, I would like to continue. We looked at different situations with different graphs. We are in section 4.3 at this moment. And we'll have a lot more graphing, but I just want to, in section 4.5, 4.5 is more graphing. But I'd like to look at a couple of problems still in 4.3. And then I'll let you choose the whole graphing situation. But I'd like to look at problems that give us information and we want to come up with an example. So if you want to, I'll show you where to choose from, and let's choose together. So I'm back to the ebook. So in 4.3, okay, come on, book. Okay, so please go to 4.3. Okay. I'm going to share my screen in 1 second to just need a second to. Okay. So I'm sharing now. Okay. So I promised a lot more graphing, but I like to look at a problem like this, like 36 or 37 or 38 or 39 or 40, because this is a condensed version of the table basically. We are asked here to sketch the graph of a function. There is more than one correct answer that satisfies all the given conditions. So if you'd like to choose, let's choose. And we'll start with that problem. And then we'll move on to 4.4. And when we go back to the L'Hopital's rule, indeterminate forms of L'Hopital's rule. With L'Hopital's rule and without. Okay, I'm ready. Anyone would like to pick, or I will?
38.
38. Very good. So in 38, I'm just going to copy, and then I'm going to stop sharing. So f prime of x is greater than 0 for all x. Okay, a vertical asymptote at x equals 1. Then the second derivative is positive for x less than 1. or x greater than 3, and the second derivative is less than 1 for x between 1 and 3. Okay, perfect. Okay, I copied it, so now I can stop sharing. So I highly recommend organize the information first. This doesn't mean anything, but if you create the table that I kindly ask you to use, please, or a version of this or something that summarizes the information, please. So let's see now what we have. So first of all, I see that the first derivative is always positive except at x equals 1. So there is a vertical asymptote at x equals 1. So the function does not exist there. Obviously, its derivatives will not exist there. So x equals 1 is a vertical asymptote. So I'm done. Don't cross it out. I'm just making a point. Then it says that the first derivative is positive everywhere. Fine. That tells me that the function is always increasing. So that is done. Now, the second derivative is positive between 1 and 3. So the second derivative positive between 1 and 3. No. Sorry, negative between 1 and 3. So negative between 1 and 3 and positive outside. Okay. And positive outside. So this is done. So positive, 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 positive. Okay. And this is done. So less than 1 is positive, greater than 3 is positive, and I put in all the information. So the function must be increasing at all times. It will open up. It will open up when it's the second derivative is positive. The function, we say, holds water, and here it does not. So now I have everything organized, analyzed, and now I'm ready to graph a function. You can come up with many other correct answers. So here is the vertical asymptote, x equals 1. So the function has to be increasing, opening up, increasing. Okay, on this side I'm going to do this. Opening up and increasing. On the other side, it has to increase at all times. It opens down till 3, so 1, 2, 3. It opens down till 3. Opens down, increasing till x equals 3, anywhere you want. And then still continues to increase, but it will open up. I made this into a inflection point. So this is what the table is telling me, where I have all the information organized, and it gave me this graph. You have millions of other options. You can draw horizontal asymptote here and do this. Or you can draw horizontal asymptote here and do this. You can do as many different situations as you can think of.